EDX Core Pure, roots of equations, using the relationship between roots and coefficients. In the previous session we saw that the quadratic equation ax squared plus bx plus c equals 0 can have the roots alpha and beta, and the sum of these roots can be given by alpha plus beta equals minus b over a, and the product of the roots would be alpha beta, and that would equal c over a. Notice a cannot be 0. So for example, if the roots of 3x squared plus 2x minus 6 equals 0 are alpha and beta, can we find alpha plus beta and alpha beta? So if we look at this quadratic equation again, then we know that this coefficient is a, this coefficient is b, and this coefficient minus 6 is c. So the sum of the roots is alpha plus beta, and we know that the sum of the roots can be written as minus b over a, so that is minus 2 over 3. We know that the product of the roots is alpha beta, and alpha beta would be c over a, which is minus 6 over 3 in this question, so that would be minus 2. So there we can see the answers previously found. What about roots of cubic equations? So now we're going to look at ax cubed plus bx squared plus cx plus d equals 0, and it will have the roots alpha plus beta plus gamma. We've seen previously that the sum of the roots, alpha plus beta plus gamma, will always be minus b over a. The sum of the pairs, alpha beta plus beta gamma plus gamma alpha, would always be plus c over a. And the product, alpha beta gamma, is minus d over a. So if we look at this cubic equation, 2x cubed minus x squared minus 2x plus 1 equals 0, if it has the roots alpha and beta and gamma, can we find the sum of the roots, the sum of the pairs, and the product? And again, if we just look at this equation carefully, making sure we pick out the correct coefficient, so there's a's 2, b's minus 1, c's minus 2, and d's plus 1. If it helps, you could list these. A is 2, B is minus 1, C is minus 2, and D is plus 1. The first thing we want is the sum of the roots. Alpha plus beta plus gamma, we know is minus b over a. So that's minus 1 over 2, which is a half. And looking at the pairs, so we've got alpha beta plus beta gamma plus alpha gamma. We know that that one is c over a, so that's minus 2 over 2 is minus 1. And then finally the product, alpha beta gamma, is minus d over a. So that's minus 1 over 2 is minus a half. So looking at the same cubic equation with roots alpha, beta, gamma, is it possible to find alpha squared plus beta squared plus gamma squared? What we want to avoid is trying to solve 3 sets of simultaneous equations for alpha, beta and gamma in order to find alpha squared plus beta squared plus gamma squared. But we can exploit quite a neat piece of algebra. If we look at alpha plus beta plus gamma all squared, so that's alpha plus beta plus gamma times another alpha plus beta plus gamma, and we start expanding the brackets, going to get alpha squared plus alpha beta plus alpha gamma. Then there'll be an alpha beta plus a beta squared plus a beta gamma, and there'll be an alpha gamma plus a beta gamma plus a gamma squared. So that may look quite chaotic at the moment, but if we collect like terms together, we get alpha plus beta plus gamma all squared. It can be written as, so if I collect the square terms together, there's an alpha squared plus a beta squared plus a gamma squared, and all the other terms can be paired up. So there's two alpha betas, there's an alpha beta and another alpha beta, there's two alpha gammas and two beta gammas. So there are two lots of alpha beta and beta gamma and alpha gamma terms. So if we look at this equation that we've created algebraically, we can now think about alpha plus beta plus gamma, which is the sum of the roots on the left hand side, and we know that that is a half. We found that already. Alpha squared plus beta squared plus gamma squared is what we're trying to find out. And now we've got two lots of alpha beta plus beta gamma plus alpha gamma, and we know from the previous slide that the sum of the pairs of the roots is minus 1. So I now have a quarter equals alpha squared plus beta squared plus gamma squared minus 2, and therefore the sum of the squares will equal 9 quarters. As we can see there. So we've avoided having to solve three sets of simultaneous equations in alpha, beta, gamma by looking for algebraic rules that we can use to our advantage. In the next session we'll be forming equations with related roots.